Welcome to Earth Science. Time for our third and final rock, and we'll go back to our original note sheet here with all this going on, and get into Metamorphic Rocks. This diagram would need to basically go like way down here before we really get to where it can reasonably form metamorphic rocks, but that's why I drew this funky little arrow thing in our original note sheets to say that at depth, if you get down pretty deep, you're going to get to a point where there is enough heat and pressure to actually physically change the minerals of the rock. And it's kind of a delicate balance. It takes some pressure to form sedimentary rock. So when all these sediments get deposited in some sort of depositional basin, they get squeezed and they're going to form a sedimentary rock. That is some pressure. For these, we're talking much more pressure. And it takes some heat in general. What we'll have to avoid, though, is it can't get so hot that it melts, because if it melts, it turns into melted rock, which then if it cools turns into igneous rocks, and we've entered a different area, So we're looking for enough heat and pressure to change the minerals, but not so much that it melts. And that's when you're going to form yourself metamorphic rocks. Now, there's a lot to it. When we get into tectonics a little bit in the coming weeks, some of this will unravel and make a bit more sense. But if you have heard the idea that the Earth has this thin crust and those chunks are moving around, and maybe you've heard of Pangea, when they used to be all unified. Sometimes there's slabs of Earth's crust that go ramming into each other. Like, for example, it's presently happening in India. India is like ramming right into Asia. It's uplifting the Himalaya mountains, and deep within the crust there, you're going to be forming some metamorphic rocks as we speak. There will be more depth when we get to tectonics, so we won't try to hack out too much today. It's just a Thursday. Let's just take a quick look at the reference table, and we'll do the same thing. I'll throw a couple of practice things at you, and then we can get into a lab, quote unquote, and get that done. So metamorphic rock identification. It's below the sedimentary one you've already used on page 7 of the reference tables. The big thing to watch out for at the beginning here, the first thing you look at when you look for these metamorphic rocks is it foliated or is it non-foliated? And what this means is, it literally means this. Is there mineral alignments? When you look at the rock itself, do you see that the minerals within that are all lined up somehow? Some of them it'll be so apparent that they're going to be like big bold stripes. And again, when we do the lab, I'll be a bit more obvious here. We'll see some examples. You'll be okay. Banding is a really bold, obvious form of mineral alignment where there's I usually say zebra stripes. Very easy to spot lined up minerals. As soon as you see banding, boom, you got nice. Life is easy. The other mineral alignments might be a little bit more subtle, but as for usual, I'll help you out with that. That takes care of foliated, which again means mineral alignment. If we go to non-foliated, that means there's no mineral alignments. And what I want you to picture here is if you took the sandstone from the previous lab and you put it under some heat and pressure, it's like all those grains of sand. I mean, you guys know what sand is. So sandstone up here is, hey, cement together some sand. Down here is take that sand, which has a lot of quartz in it that can fuse together. Maybe you've heard the idea that glass is made out of sand. And you basically bake sandstone, and it's going to turn into this kind of generally pinkish, but not always color, but crystalline form of quartz that came from sandstone. There's not necessarily mineral alignments. Outside of that, this reference table, it's kind of the hardest of the three because I can't just give you a straight up method. Like igneous, I think, is the easiest. Way over here. When we did this, I could say, hey, look for light color, look for dark color. That gives you that way. Look for coarse, look for fine. That gives you that way. Over here, it's a little bit more, you gotta kind of just look through these and try to match up some properties. So what I'll do again is an easy assignment for today where you just kind of work this reference table, see how it goes, and then that'll just be on your own. That won't be collected, and then we'll do the lab quiz thing like we did with the other two. I'll set that up tomorrow and have it due Monday, so you got the weekend, or do it on Friday, or do it on Monday, whatever works for you. All right, more to come. Thanks for listening. Welcome to Earth Science.